Howdy, y'alls. This is the Diabolic vtutor, and we're just going to be continuing. We're just going to be doing a continuation of the Trig series. This is basically just the sine, cosine, tangent function operations. No double angles yet, but we're just going to be going over the things that we've already gone over, and maybe introduced one new thing. So that's the plan. Here we are. Starting off with, problems. We're going to have the old sine function here. Sine of x is equal to 1/2. So in this situation, there's going to be either domain restrictions or lack of domain restrictions. So in this particular problem right here, we're going to have some domain restrictions. So from negative 2 pi to positive 2 pi. So just as a reminder, if we did not have this domain restriction, then there would be infinite answers to contend with, and then we'd have to break it up into two base answers. Yes. Alright, but since we do have this one, we'll keep that in mind. So doing this particular problem, we have a ratio of 1/2, because sine gives us a ratio of opposite over hypotenuse. So quick sketch, where do we have positive opposites? Here's a positive opposite going upwards on the x-axis, so that's positive 1. And then we have a triangle here going upwards on the y-axis as well, so plus 1, plus 1. And then draw the old hypotenuse. If I can draw. There we go, okay, good enough. It's not exactly to scale as usual. That's okay. So again, we have sine of 1/2, so this is a opposite, positive opposite going upwards over hypotenuse, positive opposite going over hypotenuse. We don't have one right here because that's a negative opposite, nor do we have one right there because that also be a negative opposite. So we're only in quadrant 1 or in quadrant 2 to get to this one. So what is our base angle? Base angle here, that's going to be, what is that? Let me change the color real quick. So it's not too saturated. So we have base angle number 1, that's going to be the special right triangle 30, 60, 90 opening up to the small side, therefore this is the smaller angle, so it's going to be pi over 6. You know, because 180 divided by 6 is 30, for all you degree people out there, 30 degrees. So base angle for the answer number 1, but we do have domain restrictions. So let us think about the other answers. So this one is the smallest positive angle answer. So if we're considering all coterminal angles, then it's going to be plus. Full rotation takes us back to the base angle. So if we just add variations of increments of 2 pi or subtract increments of 2 pi, then that will take us to all the answers, again if we had no domain restrictions, but we do have domain restrictions. Should we reconcile that right now? Yeah, I think so. Yeah, let's just reconcile that. So can we subtract, or let's think about this for a moment. So we have positive pi over 6, that is our base answer, and it's well within the domain restrictions, and the domain restrictions are back to negative 2 pi and then up to 2 pi. So if we subtract 2 pi from a positive number, we should still be within the realm of the domain restrictions. So we're going to set k is equal to negative 1, and then if k is equal to negative 1, we're essentially going quote-unquote backwards to get to a negative angle. So therefore, we have pi over 6, and then we're going to subtract 1 full rotation going backwards to get to a negative coterminal angle. What is that going to be? Top and bottom times 6, times 6, times 6. So 1 minus 12 is negative 11. So we have negative 11 pi over 6. So that's going to be another answer that satisfies this particular argument that will give us a ratio of opposite over hypotenuse of 1 to 2. Yeah. And this is the other one that we found initially. Can we add 1 full 2 pi to this base angle? No, we can't, because this number is greater than 0. If we add 1 full 2 pi, we will have exceeded the domain restriction, so there's no need to go on any farther. So those should be our two answers for the red scenario. Of course, we do have the blue scenario right here. That's the reference angle, but then the angle itself is starting from neutral position all the way to right there. What is that? Well, it's pi over 6 short of a half pi. of a half circle. So therefore, the blue angle from here to there must be 5 pi over 6. So that will be our base answer. That will lead us into the triangle in quadrant 2. That's that reference triangle right there. So again, that base angle is going to be 5 pi over 6. And then we probably have some other answers as well. So what are the other answers, right? So that's just the base angle. Don't forget, if there were no domain restrictions, then it'll be plus 2 pi k to account for all coterminal angles. And since our restrictions are from negative 2 pi again, we can subtract 1 full 2 pi from this one. So set k is equal to negative 1, and then that will take 1 full 2 pi away from our base angle to get to another answer. And then we'll still be within the domain restrictions because the domain restriction is back to negative 2 pi. And we're subtracting 2 pi from a non-zero number. So we'll still be within domain restrictions. So we're subtracting 2 pi. So 5 pi over 6 minus 2 pi. But 2 pi is equivalent to negative 12 pi over 6. So thus, our other answer is going to be negative 7 pi over 6. And we'll copy our base answer, base angle for the answer, 5 pi over 6. And again, we're not going to add 2 pi to get to the next answer candidate. So if we add 2 pi and get 17 pi over 6, we're not going to be including this answer because that exceeds the 2 pi. So there's no need to even perform the operation, because conceptually, we're starting off with a non-zero base angle, a base angle that's greater than 0. If you add 2 pi, then we're going to exceed the 2 pi restriction right there. So that's it for the blue scenario. So thus, we're going to put them together. Let's just delete that. I'm just trying to clear the clutter. I'll take this right here. Okay. And that should be it for this particular problem of sine x is equal to 1/2, solving for the argument. This is, in effect, kind of going backwards from what we were doing in prior streams. Domain restrictions. We've therefore restricted our answers from infinite answers into more manageable 2 answers here and 2 answers there. But altogether, 4 answers. Should probably check the work, but I guess I'll just check it a little bit. Just a spot check. So pi over 6 leads us to this triangle. Yeah, that's 1 to 2. And then we have this one right here. That's going to be clockwise progression from here to there. Yeah, that one checks out as well. And we have this positive 5 pi over 6, which takes us to this triangle. Ratio is 1 to 2. Yeah, that seems legit. And then this one right here is negative, so we're going regularly clockwise from neutral position. This is 6 pi over 6. This is 7 pi over 6 clockwise. So it takes us to the same triangle. So that answer should be good as well. I'm just going to cross this out so I don't redo these problems ever again. Alright, next problem up. We have cosine of x. And that is equal to negative root 2 over 2. I don't particularly like this form because it's not as obvious. Well, I mean, I guess it depends. And then we do have domain restrictions. It's kind of an awkward restriction from negative 2 pi to 0. So we must restrict our answers from the negative to the 0. So no positive angles for the situation. So let's keep that in mind. So this one, again, I don't like this particular form because I memorized the special right triangle. So I prefer to have it as negative 1 over root 2. So not a particularly big deal. But let's figure out where things have happened. So cosine is adjacent over hypotenuse. We have negative adjacent because you don't put the negative on the hypotenuse for like 90-ish% of the cases. I keep mentioning that, right? But I never actually have actively addressed that. But maybe some other time, hopefully, if I remember to address it. Yeah. Okay, let's do some rough sketch. Where could our triangles potentially be for our answers? Again, we're looking at a negative adjacent, so we're either in quadrant 2 or quadrant 3. Because negative adjacent means negative x value, which means we're heading to the left on the conventional xy axis. So negative 1. There it is. And then we have a positive root 2 for the hypotenuse. So that could be positive root 2, or it could be positive root 2. If it feels weird not having a negative hypotenuse, yeah, it is kind of weird. But it's the diagonal thing. So let's just use that as a crude justification. Alright, so that's a negative 1 adjacent. We could have a... Wait, this is not a 30, 60, 90. Whoops, this is a 45, 45, 90. Okay. So this picture is not drawn to scale, so let me make it a little more to scale because I like drawings that are roughly to scale. Or at least reasonable. Okay, so we have that one right there, and then we have this one right here. Yes. So that's negative 1 opposite, negative 1 adjacent for this particular triangle in quadrant 3 with a root 2 hypotenuse. And then we have a positive opposite here, negative adjacent, and then root 2 for the hypotenuse right there. Alright, so those are the locations of our reference triangles for this particular situation. That will give us a ratio of negative root 2 over 2. We have domain restrictions, of course. So instead of basing my answer off of this positive situation, well, let's consider that first, right? So the reference angle here is pi over 4. So in short, the angle is pi over 4 short of reaching this half circle. So what is this? It's 1 short from 4, so it's going to be 3 pi over 4. That's the positive thing, but remember our domain restrictions can't be positive. So we are below 0, 0 or below. So starting here, I guess we could start here as a base for answer, but I'm going to avoid that. So rather than doing that, let's consider this other negative angle right here. That's going to be what? So 0, and then we're moving in the clockwise fashion. So that's going to be minus half circle, and then we have the spillover of pi over 4. So an additional minus pi over 4. So thus combining those two, we have negative 5 pi over 4. So that one is from here, starting from neutral to there. And again, we're starting with the negative value because our domain restrictions, we have to start at negatives because this one is cut off at 0. Alright. And then, of course, do we have the potential for other answers? Well, this is restriction up to negative 2 pi. So do we need to consider plus 2 pi k for coterminal angles, right? So think about it this way. If we add 2 pi to this particular angle, it's going to give us into positive answer zones. And our domain restrictions, we don't have any positive angles, so no. So we're not going to have positive k's. Can we have negative k values? Well, if you subtract 1 2 pi, 1 full circle, that already takes us out of bounds. So in this situation, we don't need to consider coterminal angles. Well, I guess technically we've just considered coterminal angles. So what we found, any other coterminal angles would be out of domain restrictions. So this is the only angle that we care about, from this base angle right here. So that takes care of the maroon situation. Let us go to the blue situation. So again, we can consider it in terms of a positive angle. That would be 5 pi over 4. Positive 5 pi over 4, but, you know, we're starting at 0 or below. So rather than starting with a positive default angle, let's start instead with the negative base angle from here to there. So this is pi over 4 short of half circle. And half circle is negative pi going in a clockwise direction. So we're 1 short of 4, so it's going to be negative 3 pi over 4 is the base angle from here to there. So same reasoning as before. We're not going to be adding any 2 pi to get to coterminal angles because of that reason. And then we're also not going to be subtracting any 2 pi, because if you subtract this from a negative value, it becomes a larger size than 2 pi. So we will be past the restriction point. So no need for any of those coterminal considerations anymore. This is going to be the answer for the blue scenario. We shall pair it up with the red scenario. And these two are the only answers that we will report. So there it is. Nice and clean, right? Sorry, this is just really bothering me. Let me delete those. Okay. So for this particular problem, that's it. Those are the only two answers we will get for the scenario, and then we are good to go. Next problem up is going to be some sort of tangent situation. Okay. Oh, we should not start off in blue. Whoops. So we have tangent of some sort of angle x, unspecified x, and that is equal to negative root 3 over 3. Again, I don't like this particular form. And then our domain restriction is kind of an awkward negative pi over 2. And that's x restriction, and then that's up to pi over 2. So in other words, we're just kind of relegated. Answers are relegated to the side like so. So let us begin. We have this one. I'm going to convert it into irrational denominator form. So negative 1 over root 3. You can keep it like this if you memorize it in this particular fashion. Again, if you like the unit circle, then this one's going to be in the right form for that one. But if you don't like the unit circle like I don't, then this one's the one I'd much prefer. Tanks. So tanks is equal to negative 1 over root 3. And then since tan gives us the ratio between opposite over adjacent, and then negatives could be either on either of those, unfortunately we do have to consider some negative placement shenanigans. So the negative could be on the adjacent, like so, or the negative can be on the opposite, like so. So this situation is one situation, and this is the other situation. And let's get to sketching the triangles location, the reference triangle locations. So for this one, negative adjacent is going to be negative here, and then we have positive opposite ratio, so up to right here. So that's going to be negative 1 relative to positive root 3. This is a standard 30, 60, 90. So there's going to be 2. So that is one possible scenario, and then we have this other one right here with a positive adjacent, so therefore leading here, and then we have a negative opposite, so going downwards like so. So again, positive adjacent 1 relative to negative opposite root 3. Hypotenuse is still 2 for the ratios. Those are the scenarios that we are considering, and then our domain restriction is kind of like that. Well, this one's pretty nice, right? Because this is 90 degrees if you like degrees, and this is negative 90 degrees. So technically this one and then this one. So we are restricted according to these, whoops, according to the restrictions, we are restricted between here and there. This is, again, this is positive pi over 2, and then this is going to be negative pi over 2. Recalling our interquadrant locations. So we are, any triangle we have between here and here will be valid as an answer. So it's only this one. So this one is not between. So visually we can get a confirmation because this domain restriction is a lot easier to visualize. In fact, you could just see it from the rough sketch. So easy to visualize, so therefore we only have one triangle in those, between those two restrictions. It's that one, which is what? Oh wait, I guess we didn't answer the actual angle. So the actual angle for this is from here to here. It's to the negative, right? It is 30, 60, 90, so this angle here opens up to the intermediate side, so therefore that's going to be 60 for the reference, aka pi over 3. But since we are moving clockwise from neutral angle, neutral 0 degrees, then this one has to be negative pi over 3. And it is definitely between this one and that one. So that's the only answer that we will be getting for this particular one right here. Again, we disregarded this triangle because if we consider this blue scenario, going from here neutral to this location is a positive angle that's greater than pi over 2 because we are breaking past the wall for the rotation, and then we're already past that one. So the positive direction, the smallest possible positive angle is disqualified from the domain restrictions. But then if we consider the negative angle going clockwise to get to there, visually you can see that it breaks past negative pi over 2. Which again, similarly before, it's past this particular restriction. So blue scenario for this reference angle doesn't exist because it falls outside of the domain restrictions. So that's the only answer for this problem with these restrictions. And the next problem up, we have cosine of x is equal to 1. Trig function applied to some angle x is equal to 1. So hopefully you recognize this one right here. We have no domain restrictions, so this is going to be one of those infinite answer scenario. So what exactly do we have? What's this? So this one doesn't look like a ratio, so you can manually force it to look like a ratio. So we're going to do 1 over 1 just for visual clarity, visual help, I guess. And recall that cosine gives us the ratio between adjacent relative to hypotenuse. So 1 to 1, this is where the hypotenuse is congruent to the adjacent. So this is an interquadrant situation, interquadrant angle. Angle between the two quadrants. And where do we get such a situation, right? That is, of course, the question. So, are we here? Yes, we could be right here, because for this quote-unquote collapsed triangle, recall from previous stream, or was it previous 2 streams? I don't remember. Well, older stream, maybe 1 or 2 ago. Recall that we do have a collapsed triangle where there's a 0 opposite, but when the opposite is 0, then the adjacent becomes congruent with the hypotenuse. We can kind of see it with some pseudo limits, not real limits, of course, kind of a pseudo limit. That's when we achieve adjacent is congruent to hypotenuse. So this one is valid. It starts off at 0 degrees or 0 radians. Is this one right here? Does this particular interquadrant angle work? And then no, it doesn't, because the adjacent for this interquadrant collapsed triangle is 0 over non-zero hypotenuse. So that gives us 0, not the 1. So that's conflict. So this interquadrant angle doesn't work inside here because this collapsed triangle has a 0 adjacent. So could it be this one right here? So this one right here, we also have a convergence. The adjacent becomes congruent with the hypotenuse. But here is kind of the weird thing. Since we're going in the negative x direction, the adjacent is actually negative. But like, you might be thinking, wait a minute, isn't the hypotenuse also in the quote-unquote direction? And that's probably a good question. Unfortunately, I don't have a great answer for that one. But by convention, we try to keep the hypotenuse as positive. So that's the throwaway answer. I don't know if it's satisfactory. But hypotenuse is the same magnitude as the adjacent. But the reality is the adjacent is negative since we're going in the negative x direction. So that one, if this had been -1, then this interquadrant angle would satisfy those conditions. But we don't have a negative here. So thus, this interquadrant angle is not part of the solution. So not that one. And this one cannot possibly be x either for the same reason this one wasn't. Because this one has a 0 adjacent as well, so we will get 0 over non-zero hypotenuse. So we only care about this one. And just to repeat, there aren't any domain restrictions, so we have to account for all possible solutions. One full circle rotation will take us to the coterminal angle, the exact same angle. So let's start off with a 0. So our base angle answer is going to be 0, because 0, if you just put that in here, will get you a ratio of 1 to 1. And we just need to account for the coterminal ones by doing the standard move, plus 2 pi. So if you plus 2 pi, that takes us to 1 full circle. But that's only one coterminal angle. What if you do 2 full spins? So to qualify this one, we're going to put times k, where k is an integer. And then we don't just put whole numbers, because integers could be negative values as well. So instead of just simply adding 2 pi's, we could also subtract 2 pi's to go in clockwise direction to get to the same angle as 0. So that should be our answer. We'll drop the 0 because it doesn't look nice. So all our answers will be encapsulated by this. And that'll be it. You can do a quick test as well, if you wish. So if k is equal to 0, then 0 times 2 pi is 0. So if you plug in the 0, then we are indeed at this interquadrant angle. So 0 checks out. And then you check out positive 10, or the k value. That just means that we're going to be doing 10 spins. I lost track already. No. Well, it doesn't matter, okay? Just the idea is we do 10 spins and we end up exactly back right here. So 10 checks out, seemingly. And then if we put a negative value for k, let's put like -3, for example. So we're doing 3 spins of full circles in the clockwise direction. So that's 1 spin, 2 spins, and then 3 spins. So yes, we end up at the exact same location as before. Interquadrant angle right here, that does have a positive adjacent ratio to hypotenuse. So the -3 seems legit as well. So this answer should be good. Good to go. That was with the no domain restrictions. We have to include infinite answers. And then now we get to slightly messier situations, at least potentially. So we're now looking at sine of 2x. And honestly, this one could end up gross sometimes, as mentioned last time. So this is sine function applied to some sort of double angle situation. We're not going to treat this as a double angle. We're just going to treat this strictly from an using algebraic point of view based on our trig operations we already been doing. So no special formulas for this one yet. Later on, we're gonna go over this one. It's gonna become something like 2 times sine x times cosine x. You just trudge through all these properties. There's a bunch of properties, but some of those properties are less significant than others. But again, no special formulas. We're just treating it strictly as an argument, algebraic. Alright, so we have this one right here. Let's consider the situation first when we have no domain restrictions. So how do we do this? So before, we've only worked with very standard arguments. Basically, argument is just one letter. There aren't any numbers around it except for one. So we've already worked extensively with these type of problems, but now we have a 2x doubling the input kind of scenario. It's honestly not too bad. You basically treat it exactly like how we would treat this particular problem. So I guess let me show. So let's consider something where I'm just going to leave it as generic angle right here. So sine of generic angle is equal to -1/2. So we won't consider this one just yet. We're focusing on this one first. So let me partially put that off screen. So doing this one right, we basically sketch the triangles that will give us a ratio of -1/2. And there are 2 particular locations where we have a negative opposite. So negative opposite 1, and then we have negative opposite 1 right there as well. So sketch the triangle here. That's going to be one reference triangle, and there's going to be the other reference triangle. Hypotenuse. Alright. So how did we do this problem? Again, considering that there are 2 possible scenarios, we can get to this first reference triangle. That's going to be a full half circle. That sounds weird, a full half circle. That's just going to be a half circle with a little bit of spillover. It opens up to the small 1. So the spillover is just 30 degrees, aka pi/6. So half circle is 6 pi/6, so you just add one more pi/6, getting 7 pi/6 to get to this reference triangle. And of course, if we wish to encapsulate all answers, since there aren't any domain restrictions, then adding extra 2 pi's should take care of that. So plus, standard move right here, 2 pi times k, where k is an integer. I think some people tend to use n for this. I've seen those type of situations. So you might see it written as 7 pi/6 plus 2 pi n. It doesn't matter, and then you just say n as an integer as well. Don't say n is a number. If you just say n is a number, well, irrational numbers also work too. This would be saying that messy numbers are permissible. So for example, 1/2 or pi is permissible, and then you're not going to get whole increments of 2 pi anymore. So this one, that's why I don't like n in particular, because it feels like just a number. So you have to qualify that one. N is an integer. As long as you specially qualify it, then it should be fine. So this is acceptable, but honestly I prefer k. I don't know why I prefer k, but... Oh, I guess I just said it, right? I feel like n is just a number. Okay, so that's that one for this one. And then we would basically... done with the red scenario, and then you just apply it to the blue scenario as well. So theta for the red situation could be equal to that. And then we also have the blue situation going from here all the way to there. This is going to be pi/6 short of full circle. So full circle is 2 pi. Doubling the 6 is 12. So we're 1 short. We're 1 pi/6 short of a full circle. So 12 minus 1 short is going to be 11 pi/6. That is the base angle we're going to be adding on to. So it's going to be plus, just to capture all the coterminal angles, 2 pi k. Standard move right here. K is integer. and that's answering capturing all the answers for the blue scenario. So answer number 1, infinite answers for scenario number 1, and then infinite answers for scenario blue. And that'll be it if we were answering this particular problem. So we already know how to do that, but now we have a confounding thing with this times 2. But again, it doesn't really do that much to change the problem. So the only thing happens is we're not dealing with this anymore, right? So let's delete this one. Well, let's delete this one. If you think about it, solving for this one is solving for the entirety of 2x. So the theta was like here, right? So solving for sine theta, sine of some sort of one consideration as an argument, it's going to be the theta. But what are we hiding here underneath the theta? It's 2x. So instead of just putting theta, you just put 2x right here. Same thing for the blue scenario. Instead of putting a theta, thinking about it as one whole number, think about it as 2 times x. So you don't put theta, you put 2 times x. That's the argument right there. And now we can just do basic algebra, divide both sides by 2. So divide by 2, and then divide this junk by 2 as well. So we're going to get x is equal to, divide this one by 2. 6 times 2 is 12, so that's division by 2. Goofy flip trick. And then plus, divide by 2. Leave the k alone because we already canceled one of these factors. So that is going to be the answer for scenario red. It's no longer this triangle as the reference. It's half of that, right? Which ends up somewhere in quadrant here, in quadrant number 2. So not too bad. Same thing, we're going to do the same operation right here. We're solving for x using basic algebra, so divide both sides by 2, so divide by 2. I should circle the whole thing. So divide by 2 means you multiply half to the entire fraction, so we get 11 over 6. I mean, 6 times 2, which is 12. So 11 pi over 12, and then this one, divide by 2 as well. All terms. And that should encapsulate all our answers. We should still put k as an integer. So 2 answers where k is an integer. And that should capture all our answers, and thus we have successfully answered this particular question right here. So I guess it wasn't too bad. It's just kind of annoying. It's just one extra step solving for the letter itself. Anything else I wanted to mention about this problem? Well, I guess we should test it real quick, right? So maybe maybe it might seem a little dubious. So this answer looks weird, right? So let's just try it real quick. We're gonna test it for k is equal to 0 for the situation. So 0 times pi is 0. So take this answer, and then we're just gonna plug it directly into there. So 7 pi over 12 times 2 gives us 7 pi over 6. 7 pi over 6, that's going to be past half circle. How much? By pi over 6. So the reference angle is a 30, 60, 90 with the 30 opening up to the negative 1. Going to the left on the x-axis is negative root 3. Hypotenuse, keep it positive as 2. So sine of this result that we calculated is opposite over hypotenuse. So this checks out. Seems legit. We can just do appease the paranoia. Let's check this one test this one as well. I was trying to say test and check at the same time. Let's check this one as well. Let's instead of plugging 0 like last time, let's plug in a negative 1 just to be goofy, right? So negative 1 times pi. So we're going to be taking away 1 full pi. So 11 minus 12 is going to give us negative pi over 12. So that is what we're going to plug in to test. See if it works, right? So we're plugging in negative pi over 12. If we multiply it by 2, then we get negative pi over 6. So what is sine of negative pi over 6? So doing the rough sketch. Negative pi over 6 is in the clockwise direction. It's the small angle 30. So 30 opens up to 1, but we're going down y-axis, so it's negative 1. And the hypotenuse is 2. So yes, it returns negative 1 over 2. Checks out. So that's some good evidence that answer number 1 is good, and answer number 2 is also good. You didn't have to test it though. But I do advise testing it when you're starting off with these type of problems. That way you get used to the crunching the numbers as well. Because there are some problems that are fairly tedious. And next problem, we do have a tangent situation right here. Tangent of 3x. Which is equal to negative 1. You could always force this into a ratio by putting it over 1 if you wish. So consider that we do have negative 1 adjacent relative to 1. I'm sorry, negative 1 opposite relative to 1 adjacent. Or, just move the negative sign, we have a positive opposite ratio to negative 1 adjacent. Those are the considerations. Do we have any domain restrictions? Let's put some domain restriction. Let's do without domain restrictions first. So unlimited answers first. So considering scenario number 1. For the triangle sketch. So we're just trying to find a reference angle first. So where do we get a negative opposite with a positive 1 adjacent? Ratio. So here's a negative opposite, but this is a negative adjacent, so it's not this one. So it's going to be this other one right here. Negative opposite, positive adjacent. So that's a rough sketch for red scenario from here to here. From neutral to here. So that's going to be negative pi over 4 for the clockwise movement. Or, you could go the other positive route. So that would just be pi over 4 short of 2 pi. So 8 minus 1 is 7. So the angle that represents this one is going to be 7 pi over 4. So it doesn't matter which one you use. You can use this one as the basis for your answer report. Or you could use that one as the basis for your answer report. It just depends on the domain restrictions and whomever's grading you, right? Well, we have no domain restrictions. So I'm going to base it off of the positive one, just because I'm biased towards reporting positive answers as a base. So starting from here, again, no domain restrictions. So just putting this one here into a tangent function. So we're not considering the 3 at the moment. But if you just take this angle here and you put it into a standard tangent function, then we're going to get a ratio of negative 1 to 1. So that's all we care about, right? So we acknowledge that putting 7 pi over 4 into tangent function gets us this ratio. So therefore, any coterminal angles with this one will also give us a ratio of negative 1 to 1. So all you need to do is count for all coterminal angles by putting plus 2 pi k. K is an integer, of course. But here's the thing, though. Now we need to consider what is our actual input. It's not just a generic theta. It is in fact a 3x. So to reiterate, if this had been theta, then yes, we just put theta is equal to this as a base angle plus all the coterminals, and this would be our final answer. But we don't have generic theta. We have 3x. So you just make this whole thing 3x is equal to all the possible scenarios. Solve for x. So divide by 3, divide by 3. Thus yielding x is equal to kind of a nasty 7 pi over 12. And then plus 2 pi k over 3. And then we can end it right here for the red scenario. If you wish, you could factor out some fractions if you want to make it look, I don't know, more beautiful. It's up to you though. So if you wish, you can factor out 1 over 12. Thereby getting 7 pi plus, what is that? Divided by my brain. Sometimes it doesn't work very well. 8 pi k. Yeah, I think that's it, right? 8 divided by 12 is 2 over 3. Yeah, 2/3. Okay. So you can do it like this. It's a little extra though. If you like whole numbers in front of the pi's, you can do this. Fract out the 112. But honestly, is it worth it? No. I'll just leave it like this. Good enough. That takes care of red scenario. But don't forget, we have two possible scenarios. This is the only one we've addressed. We need to address this other one. Okay, no domain restrictions. So we can draw it here. Well, I'm just going to do a separate drawing altogether. So we're looking for a positive opposite with a negative adjacent. So here's positive opposites. This is the negative adjacent. This is a positive adjacent, so not quadrant 1. So only quadrant 2. Alright, we have a positive 1 opposite ratio to the negative 1. This is going to be standard 45, 45, 90. So from here to there. This is pi over 4. We're pi over 4 short of half circle. So 4 minus 1 is 3. So this angle is 3 pi over 4. That's the basis of our answer. We have to account for all coterminal angles since we have no domain restrictions, so plus 2 pi k. Again, this is going to be the answer if we had a standard problem like this. If the argument was just theta looking, and that is equal to negative 1 over 1, then we would report this theta would equal what we just got. But our problem is not written like this. It is written instead with 3x as the argument. So it's not just a plain theta. It's actually 3x. So 3x here and then 3x. Solve for x. So divide all terms by 3. So divide by 3, divide by 3, divide by 3. And that should encapsulate all our answers. I'm not going to test it out, so I'm going to say it's good enough. I guess we should just do one test, right? Let's test for k is equal to negative 1, just for this answer, because I'm feeling kind of lazy. So testing for k is equal to negative 1. If k is equal to negative 1, then this becomes negative 2 pi over 3. If we add it to positive this one, it will become 3x. I'm sorry, not 3x. 3 pi minus 8 pi over 12. Which is equal to what? Negative 5 pi over 12. There it is. Negative 5 pi over 12. So we're going to plug in negative 5 pi over 12. So that's going to get tripled. So when we multiply by the 3, divide by 3, divide by 3. So that becomes negative 5 pi over 4. And this one is going to be clockwise past half circle because 5 beats 4 by 1. So that's a spillover of 1 pi over 4. What kind of ratios do we get if we're applying tangent to this reference triangle? It's going to be negative 1. It's going to be positive 1 to negative 1. And that is in agreement with the problem, so it seems legit. So we got answered. We gotta delete this negative 1 plugin, right, for the check. Let me erase this. Alright. So just to reiterate, this is good, and then that is good. It should be good. And that's it for this particular problem with no domain restrictions. And I think that's good enough. So now we're just going to be getting a bunch of those ones where the argument is modified now. So no longer just perfectly nice anymore. So next problem up, we have sine of x over 5. So no longer just like a regular argument of x. Instead, we got x over 5. So no need to be intimidated, just standard operations with one more step than usual. So is equal to negative 1/2. And this time we do have domain restrictions just for extra annoyances. In fact, I would say having these extra restrictions, if they're weird restrictions, end up being more annoying than not having restrictions. So we have negative 4 pi is one end of the wall restriction for domain, and then we have on the other side of the wall 4 pi. So non-standard restrictions, but it's okay. We'll just treat it like any other problem, right? So start off with the ratio. So what sine function is applied to what overall angle will give us a ratio of negative 1 to 2? Well, sine gives us opposite over hypotenuse. Again, don't put the negative on the hypotenuse. Just put it on the opposite. So that means we could be in quadrant 4 or quadrant 3. Going downwards is negative opposite. So not quadrant 2, not quadrant 1. At least before we consider this division by 5, okay? We're not considering that at the moment. We're just considering this whole thing, the whole argument. So let's break this down into red situation. So red scenario is here. This is a standard 30, 60, 90, opening up to the 1, negative 1. So that's just going to be pi over 6 as our base angle. And we need to consider the coterminal angles if there were no restrictions. So that's going to be plus 2 pi. Plus 2 pi k. K is integer, of course. But we don't have a standard argument. We have an argument of x over 5. So let us set this equal to x over 5. So whatever the true angle is, once we divide that true angle by 5, then it will give us this thing right here. And having this thing right here, if we plug it in, will give us a ratio report of negative 1 to 2. And now we just need to solve for x. So x is equal to 2 times 5 to both sides. So we're going to get 5 pi over 6. Gorgeous. And then plus very awkward 10 pi. That's really funky. That's okay though. So let's consider our domain restrictions. The domain restriction is up to 4x. If we're adding increments of 10x, this one right here will take us well out of the domain restriction. So, because 10x takes us well past 4x, right? So we don't need to add any positive 10x's. What about subtracting 10x's? If k is a negative value, right? That will still take us past the other wall barrier in the other direction. So if you subtract 10 pi, that's well past this negative 4 pi. So no need for much considerations. We will delete this portion right here. So this is unnecessary because, again, adding or subtracting increments of 10 pi will take us out of domain restrictions. So our only answer, therefore, is just 5 pi over 6. So no. The answer for the red scenario is finished. And then we just need to consider the blue scenario. What is that? So this is going to be half circle pi. We're leaking past it by pi over 6. So 1 plus 6 is 7. So from here to there is 7 pi over 6. Because again, 7 is 1 past 6. So that's our base angle. Consider all the coterminal angles, which is just going to be plus 2 pi k. What's our actual argument? Our actual argument is x over 5. And like before, we're just going to solve for x, multiply both sides by 5. So we're going to get 35 pi over 6. That's wonderful. And right here is going to be plus 10. Plus 10 pi times k. So that one is highly suspicious, right? Because 35 divided by 6, that's close to 6-ish. So 6 pi-ish. That's already past this one. 6 pi is already past 4 pi. So this one as a base answer doesn't work. But let's consider the situation, right? If we subtract or add 10 pi. So this one takes us past the positive domain restrictions. It's well past 4 pi. So to get other answer candidates, it doesn't make sense to add any more 10 pi's to it because this is already past 4 pi. So thus, we will only consider negative k values. So if the k value is negative 1, negative 2 is probably too much, and then negative 3 is probably too much. Let's consider k value as negative 1 first. If the k value integer is negative 1, then we are applying one of those in a clockwise fashion. So it's going to be minus 10 pi. So start off with the base angle, 35 pi over 6, and then we shall do one full rotation. So minus pi over 10. I'm sorry, minus 10 times pi. What is that? Top and bottom times 6. Minus 60 pi over 6. What does that yield? Well, that gets us a 25 pi over a negative 25 pi over 6. And unfortunately, I think this is out of domain as well. Because if this had been 24 pi over 6 would give us 24 pi over 6 would give us a negative 4 pi. That's already on the wall of the restriction. 25 is greater than 24 in terms of magnitude. So this one takes us past negative 4 pi, and that was our restriction right there. So therefore, we have no solutions for the blue scenario. So empty set for blue scenario. Yeah. Since the restrictions are specifically phrased on the x, not the argument as a whole, then the whatever x's we solve for have to be between this one and this one. And since the blue answers, none of them are between negative 4 pi and positive 4 pi, then we have no solutions for the blue scenario. So that was kind of awkward. We only have red solution right here. So thus, for final answer for this particular problem, x is equal to, what was it? 5 pi over 6. And that's the only answer we have for the scenario. And we can just test plug it in real quick. So slam dunk that in. We're going to get 5 canceling with 5. We get pi over 6. This whole thing becomes pi over 6 once we plug that in. And sine of pi over 6. What is that? Quadrant 1. 30, 60, 90. This is a ratio of 1 to 2. So 1 to 2 ratio, yeah. Oh, it's negative. What? What happened? Okay, something's a little weird. Something's a little weird. Thank goodness I tested it out, right? This answer is not correct because I based it off of a positive pi over 6, but it's supposed to be negative pi over 6. Okay, that explains it. So again, I use the reference angle pi over 6, but that's not the true angle. The true angle is negative clockwise fashion to get to here. So that's negative pi. over 6. So this one should have been negative pi over 6. We could easily rectify that. Let me move this around. So that's supposed to be negative. Negative pi over 6, and that means, let's consider this again. Negative pi over 6, and then plus, what was it, times, multiply 5 to both sides, so this becomes negative 5 pi over 6. Just to retrace the work, times 5 to this one, so that's plus 10 pi k. So same argument as before, adding any increment of 10 pi or subtracting any increment of 10 pi will take us well past the domain restriction, so let's ignore this. So we only have this one right here. And I think that's the only answer we need to consider, right? Negative 5 pi over 6. So now we're testing negative 5 pi over 6. So this whole thing becomes negative pi over 6. So fixing the sketch. This is negative pi over 6. So it's right here. That's the negative 30, 60, 90. So this is going to be negative 1 opposite to positive 2 hypotenuse. So this negative 1 to 2 is good to go. Yes, and we are well within domain restrictions. Because 5 is less than 6. That's already less than the smaller size of the negative pi, which is definitely before this one, or after this one. Okay. And I think we're good to go for that particular problem. Yeah. I guess this is why I don't usually use a negative for the base angle. I shouldn't have used pi over 6 to begin with. I should not use this one, because that's not usually how I do it. I probably should have done this angle, which is going to be 11 pi over 6. This one should have been my base value. Wait a minute. Oh wait, because we haven't times 5 yet. Let me consider something real quick. So we have times 5, and that's past 4 pi. Yeah. Okay. That's fine. So if we started with this as a base angle, we would simply need to subtract a 10 pi just to see if we have valid answers. Yeah, that's basically how we would proceed from this very problem right here, right? Yeah. You know what? This problem is essentially done. So this is the answer for the problem, but let me just explore something just a little bit. And the exploration is, what if I didn't use negative pi over 6? What if I used the positive coterminal one, which is going to be 11 pi over 6? Let me see how annoying the operations would have been. So we will multiply both sides by 5. And then thereby getting, what, 55 pi over 6? That's nasty. And then this one's times 5 as well. So same thing as before. So 55 divided by 6 is 9 pi-ish. And then 9 pi-ish is well past 4 pi. So this, as a base answer, is outside of domain restrictions. So adding 10 pi's would take us even farther beyond. So at that point, we can only add negative 10 pi's. And it only makes sense to only subtract 1 10 pi. So that's minus 60 pi over 6. So thus simplifying that, we're going to get negative 4 pi over 6, which is interesting because this is deviating from our prior answer. Right? Huh. That's interesting. This answer works out. Let me make sure I'm not goofing something up. Let me make sure. Yeah, this one is... That one is coterminal to this one, because it's 1 pi over 6 short of full circle. That's true. then times 5 to both sides, so this is correct. And 10 pi is equivalent to this one. Yeah. And subtracting that, oh, I just did the math incorrectly. Okay, good. So I don't know why I put a 4 here. Okay, it's consistent. It's consistent. So this is not 4. I don't know why I put a 4 here. I just can't do math. I'm not a real math person. So we have negative 5 pi over 6. No simplification to be done here. Yeah, so this would be consistent with what we've gotten before. Consistent. Okay, I just want to double check that. VOD watchers, definitely skip that. Unless you want to watch. It doesn't hurt. Okay, now the problem we have here is another fractional situation. We're going to have cosine of 2/3 x. You know what? Let's be goofy about this. Let's make this a negative. We'll have like a reflection or something. Let's do a negative argument. Negative 2/3 x. Just for hilarities, and then we have is equal to 2. Will give us a ratio of root 3 over 2 with a negative in front. Do we have domain restrictions? Yes, we do. So domain restrictions. I'm actually going to change this one just a little bit. It's going to be negative 3 pi. Let's do a bigger one actually. Let's do negative 6 pi just to be annoying. So let's expand the restrictions. Wait, that sounds weird. Expand the restrictions. Let's expand the range of our potential. No, I shouldn't use range because range is for y values. Let's expand the domain. Domain expansion. So that one right here, and then 6 pi. Okay, there we go. So that's the problem. The reason why I did this one, because I know that 2/3 is going to give us some bigger angles. And just having the restrictions of negative pi will probably exclude a lot of answers. I want to make this problem kind of annoying, that we have to check for multiple answers. So should be good. That's the problem. Start off here. Cosine gives the ratio of adjacent relative to hypotenuse, so don't put the negative on the hypotenuse. Put the negative as a consideration on the adjacent only. So negative adjacent scenarios will be in the negative x direction. So that's going to be negative root 3. We have a positive 2 for the hypotenuse here, or there. So those are the two possible reference triangle shenanigans, I mean scenarios. Let us partition this into two parts. We have the right angle right there. This is going to be opening up to the 1, so this is going to standard 30 degrees. Pi over 6. That's the reference. So this whole angle here is going to be 5 pi over 6. So that's the base angle answer. We need to capture the coterminal angle, so plus 2 pi k. But we need to consider the actual argument modifications. That's the actual modification. So we set negative 2/3 x is equal to all the coterminal angles. I guess I don't really need to move this. Let's put it right here. So that's the base angle. That's our actual argument right there. And let us solve for x by multiplying both sides by negative 3 over 2. So reciprocal with the negative clears that one. We get positive x, which is what we want. This one distributed to that term is going to give us negative what? 5 pi over 4. Yeah, that should be correct, yeah. And then distributing this one to this one gets us a negative 3 pi. So you could actually leave your answer like this, but because k is an integer, this minus thing doesn't matter. So, you know, if you don't like having negatives as the answer, you can just put this as positive. And having negative integers for k will correct for that. In the same line of thinking, if you had kept this as negative, it doesn't really matter. So this could be your answer. It's acceptable. This could also be the answer because, again, the k corrects for the signage right here. So I'm just going to leave it as positive because I prefer positive for the final answer. Alright, so that should be all the answers for the red scenarios if we don't have domain restrictions. But we do have domain restrictions. 6 pi is the wall and negative 6 pi is the other wall. We're adding increments of 3 pi, so that is a thing to consider. So we can do positive k values up to 2. The reason being, if we multiply, if k is 1, then we are adding 3 pi to a negative value. We'll still be within the bounds. 2 times 3 pi, okay, if k value is 2, then we're adding 2 times 3 pi, which is plus 6 pi, to a negative base value. So we should be well before the wall for this one. So that's my consideration. We're going to test over those ones. It doesn't make sense to test for, I guess we do need to test the negative values as well. So 0 as a base value for k should work out, since we should fall well within these two restrictions. So 0 should work, and then if you take away 3 pi, if k is equal to negative 1, we're taking away 3 pi from a negative answer. That should still fall within our domain restrictions. But I think 2, if k is equal to negative 2, that would be pushing it. If you understand what I'm saying. So if we inputted negative 2 for this k value as an integer, this whole thing will become minus 6 pi. Since our answer base is already negative, then subtracting 6 pi will take us farther right past this one. So the negative 2 is not for consideration. So these values for the k should take us to all the relevant coterminal angles. So let us do that. So if k value is negative 1, we're going to be taking away 3 pi from here. I'm going to show this work. Let me think about this. You know, just to make this one a little more conducive, I'm just going to transform this one into something with a 4 for the denominator. So I'm going to rephrase this real quick, just to make plugging this in a little easier. So copy paste the base angle, and then this one right here, I'm going to change it to a denominator with 4. So plus 12 pi over 4. And those are the k values we're going to be testing, or not testing, but we're going to use these k values to generate all our possible answers for the coterminal angle considerations. So this one plus minus 1 times that. So we're only taking away one of these ones from this one. So that's going to give us negative 17 pi over 4. So that should fall within domain restrictions. So negative 1 is good. Plug in the 0. Well, that just gives us the base angle. That one should be well within domain restrictions. Plug in a 1 into here. So we get negative 5 plus 12 is positive 7. Positive 7 pi over 4. So consider that coterminal angle is done, and then now plug in a 2 into the k, which gives us 24 minus 5 is 19. So 19 pi over 4. So these 4 answers should be within our domain restriction. We'll double check that out. You know what, let's check it out right now. So is this one indeed between wall number 1 and wall number 2, right? Well, this one, if you're comparing it to this one, that's going to be negative 24 pi over 6, which 17 is definitely within that boundary. So that one's good. This one, it should also be within the bounds. So this is 6 pi. That's in comparison as a fraction. That's going to be 24 pi over 6. And 19 is definitely less than 24. So that one's good. Should be good, yes. I think that's... Wait, did I misspeak about this previous one? Let me think about this. I said negative 24 pi over 6, right? Yeah. Wait, why did I do over 6? It's supposed to be over 4. I'm sorry. Over 4. Yeah, over 4. And that's correct. And this other one, it should have been positive 24 over 4. I hope I said that correctly. Yeah. So all 4 of these answers are well within the domain restrictions right there. So we should be good for that one. Okay. So that only takes care of the red scenarios, but what about the blue scenario from here to there? So that's 1 pi over 6 past halfway point. So that's going to be 7 pi over 6 for the blue scenario. This is our base angle. We need to consider the coterminal angles for that one. So plus 2 pi k. But that's only if our base argument was just theta. We don't have just theta. We have negative 2 over 3x. So don't write this. Negative 2 over 3x. So at this point, just algebraic manipulations are going to multiply both sides by negative 3 over 2. So thus, we solve for x, which is what we want. This one times this one is going to give us, what is that? Negative 7 pi over 4. Yeah. And this one times this one gives us negative 3 pi k. Again, since k is just an integer, this negative is technically correct, but I like to keep it positive answer. It's the same thing. Alright, so k is an integer, keep that in mind. We do have domain restrictions up to 6 pi and back to negative 6 pi. Since we're starting off with a negative answer right here, 0 for a k value should work. And then 1, we're just adding 1 3 pi, so that should work. And then 2 for the k value should also work, because then we're adding 1 6 pi to a negative answer, so that should take us before 6 pi. We will stop before 6 pi, which is the domain restriction in the positive direction. So those are the only k values that we're considering. Now let's consider the negative k values. So if k is negative 1, we're only subtracting one of these from here. That should work. Negative 2 should not work because this answer is already negative. If we specify k is negative 2 as an integer, then we're going to be minusing 6 pi to a negative value. That's going to take us past this particular restriction. So negative 2, nope, we're not going to do that one. So thankfully we only have 4 answers again, but let's crunch the numbers. Again, this one right here, I'm going to change it to something with a denominator of 4 just to make the mathematics a little easier. So that's going to be 12 pi over 4. So plugging negative 1, if the k is integer negative 1, then we're going to get negative 7 minus 12, which is negative 19 pi over 4. Answer number 1. So finish with that. If k value integer is 0, then we just keep the base angle. Done with that one. And then if the k integer is 1, then we're just adding 112 to a negative 7. So that'll give us 5 pi over 4. Done with that. Lastly, if k value is 2, then we have 24 minus 7, which is positive 17 pi over 4. Alright. You could technically just get the answer 2 by taking this 12 here and just adding it to the top. So negative 19 plus 12 gets us to -7. And then you add another 12 to this one to get to here. And then you add another 12 to this one to take us to the next one. Yeah. So that's actually a pretty good strat as well. So if you weren't considering domain restrictions right off the bat, you just take this 12, add it to this one, you get 29 pi over 4. And 29 divided by 4 is greater than 6, which means it's passed. So you could just stop, cross that answer out, keep it right here. Actually, that way might actually be faster. You just get the base angle right here, and then you just start adding 12s to get to your potential answers, and then you subtract 12 to get to your other directions, and then you just cross out the ones that are well past those two restrictions. Yeah, it actually might be faster. That's okay though. Alright, so combining the two answers together. Ooh, that's ugly. So we have in total 8 answers. So this one, this one, this one, this one, that one, that one, that one, and that one. So 4 answers for this particular problem right there, and we should be good to go for this problem. I'm not going to check it. I probably should check. Just, yeah, okay. You know what? I can't help it. Let's test arbitrarily this one. So that's one of the red scenarios, and let's test arbitrarily that one. But the problem is essentially done. We have 8 answers, but let's just, you know, do a quick test. So if we plug in this one first, we have the 19 pi over 4 times -2 over 3. What does that give us? I guess it's kind of a bad number. We're going to have -19 pi over 6 into our cosine function. What does that give us? I guess this is a good review, right? Just reviewing our mechanics for crunching the numbers. This one here is exceeding 12 because 6 times 2 is 12, so this one needs to be reduced. We're going to reduce it by adding 1 full rotation, which is plus 12 pi over 6. So that takes us to a reduced value of -7 pi over 6. That's a coterminal angle, which is easier to work with. So if we quick graph this one, that's clockwise direction, we're past half circle. So this is going to be our reference triangle of 30 degrees, pi over 6. So the adjacent is -√3, the hypotenuse is 2. So should we get -√3 over 2? Yes, we should. So that is good evidence that this answer is good. Alright, so that's the first test. First test is good to go. Second test should work out as well, right? So let's test this one. If we put this one into the x, then it gets multiplied by -2/3. What do we get? Negatives cancels, so we get positive. And we have 7. The 2 cancels with the 2 on the bottom. So we have 6 on the bottom, yes. Oh, we just tested this one. So thankfully that should work out. So not to be redundant, but that's good habit. Let me just go through this one. This is plus 7 pi over 6. Oh, this is the opposite direction, so this one right here. So this is a classic 30, 60, 90 scenario. So this one opens up to a -1. We don't care about that. The adjacent is -√3, and then the hypotenuse is 2. We're doing cosine. So that's -√3 over 2. Consistent. So this answer hypothesis is also good. So we took a random sample of 2 out of 8. That's 25%, so it should be good, right? That's actually kind of a lot of work. Okay, well, we're done with that problem, at least. Let me take a quick drink. So it's not too bad. Maybe I oversold the annoyance of those particular problems, but yeah, I guess they're not too bad. And next up, we're moving on to a kind of a different presentation of the problem, but ultimately the problem is pretty much the same thing. So, next problem types, we're going to have tangent of x. So we're back to regular old x is equal to -1. So if I've just given this one, we have infinite answers, but here is the bonus. We have cosine of x is equal to -√2/2. And here's domain restriction as well. So again, ultimately the same type of problem, but a different presentation, different framing, and then the question asks, what is the value of x in this situation? So again, kind of weird. We're more used to just seeing this particular problem with this one, and then we're just solving for x. That's fairly typical. But now we have one more piece of information, one more statement right here. So let's just take it one at a time. Let's consider this piece of information first. So if we're just looking at this one right here, only considering this one. So that's going to take us to possible scenarios, like where are the reference triangles possibly. So -1, we can change it deliberately into -1 over +1, or +1 over -1. Where does that one end up? It ends up being negative opposite over +1 adjacent. So right here could get us to this situation. So that's one possible reference triangle right here, and then the other one is on the flip side. So that's where we have a positive opposite but a negative adjacent. That's the reference angle right there. So from this clue alone, we can have this for an answer, which is going to be 3π/4. We could also have this for an answer. Oh, let me put different colors, I'm sorry. This is one possible situation, 3π/4. That's only one answer, considering all coterminal angles plus 2πk without domain restrictions, right? And then the other scenario is this one. This is 1π/4 short of full circle 2π. So this entire angle is going to be 8 minus 1, which is 7, so 7π/4. That's the base angle answer. Consider all the coterminal angles plus 2πk. So that would have been the answer if we had no restrictions and we're just doing this particular part. But we do have restrictions. And in addition to that, we have this piece of information right here as well. So what does this tell us? Let's use a different color. So this piece of information tells us what about angle x, which is the same angle as that angle x, right? So what does this one tell us? So if we were to sketch out the potential triangles for this one, well, I don't like this number, so it's going to be -1/√2. So we have negative adjacents, so it could be -1 adjacent here. Relative to √2 hypotenuse. Or it could be negative adjacent to this other one. So that's the second reference triangle. Different opposite, but same ratios for adjacent over hypotenuse. Let's consider the scenarios. So this one could be positive 3π/4. And then the other one, that one could be 1 plus 4, which is 5, so 5π/4. For the base answer, but considering all potential coterminal angles, we have plus 2 pi k. All possible coterminal angles, plus 2 pi k. And here's where we have some conflict, and this is where the problem gets kind of spicy, so to speak, right? If you're doing tangent of x is equal to -1, then we have two possible base reference angles. We could have this one for the reference triangle, or we could have this one. That's for some angle x. However, for the same value x, for the cosine, this is one possible scenario, this is another possible scenario. So if you meld these two pieces of information together, if you meld this one with this one, then there could only be one true situation, and that's the situation in quadrant 2. Because both of these statements consider the possibility of something happening in quadrant 2. This is in quadrant 2. This one is not a possibility for this situation, and this one is also not the possibility for that situation. So what does that mean for us? It means that by melding these two pieces of information together, I guess melding might not be the best word, but just considering these two together, this is the only valid situation that satisfies both mathematical statements. So this one satisfies that, this one satisfies that, both of them in fact. And yeah, I'm going to leave it like that. So we only have one scenario to consider, and that's the red scenario. So only this situation. Blue situation has been discounted, so no, and no. Alright. I guess these two blue situations are different. I should not have colored them the same blue, but that's okay. The red one just coincidentally happened. So now that we've narrowed down the search by putting these two pieces of clues together, we've narrowed down the angle search to 3 pi over 4 plus 2 pi k. This is without domain restrictions. We do have domain restrictions. Alright. So it doesn't make sense to consider negative values for k, because if k is -1, for example, we're going to be subtracting 2 pi from this base angle, which takes us to negative values past our restriction point. So we're not going to be considering negative k values. Can we do 0? Yeah. If k value integer is 0, then this whole thing is gone. We are left with 3 pi over 4, which is well within restrictions. So let's report that as the first answer. Alright, and then of course, if we add one full 2 pi, that will take us already past the domain restriction. So in fact, this is the only answer that we will consider. So 3 pi over 4 for all these clue bits and pieces right there. So only one answer, 3 pi over 4. And we are good to go for this problem. Let me see the time real quick. Okay. Hydration real quick. So which problem was, oh, that was the first of this different set. So moving on to next problem. We're going to have sine x is equal to √3 over 2. So just by this clue alone, we have two possible main scenarios. And if no domain restrictions, then we have to account for all coterminal angles. But we have an additional clue. We have an additional statement, I mean. We have tanks is equal to -√3. So putting these two answers together will narrow down the search for angle x. And then we have one more thing. Cosine of x is equal to what? So that's our question. So here's the situation. This one right here, if we consider the possible scenarios for the x one, it will generate two possible scenarios. What situations will it generate? it's going to give us scenario number 1 or scenario number 2, and then this one generates its own possible scenarios for the x angle. It could be this one right here, negative adjacent, or it could be the negative opposite. And all you need to do is put these two clues together and say, oh, this one shows up in the first scenario, and it also shows up in the second scenario. This one right here is inapplicable in tan x, and this one is unapplicable to that one. So that's what's happening in terms of the mechanics. Two statements will help us narrow down the ambiguous situation. Alright, so that's the overarching idea. Let's go through the actual mechanics. Let me colorize this just a little bit. Okay, so in consideration of scenarios, this one right here will generate, again, two possible main scenarios. We have a positive root 3 opposite, so this is one situation relative to 2, and then we also have this other positive opposite relative to 2. Okay. So I'm not even going to bother generating the angles because that's going to be a waste of time because we need to consider this one. So possible scenarios for this one. This is not a fraction, at least it doesn't explicitly look like a fraction, but you're always entitled to put it over 1. So we have negative root 3 over 1, or we can have positive root 3 over negative 1. So if you know how to skip your work, you can skip your work, but let's not fully skip work. What is this possible scenario? Negative opposite root 3 over positive 1 adjacent. So this is one possible scenario. What's this other one? We have a positive root 3 opposite over negative 1 adjacent. And putting those two statements together, we can conclude that the only valid scenario is the triangle is a scenario that's arising in quadrant 2. That's consistent across both statements. Alright, so what does that mean? Well, let's figure out the base angle that leads us to this reference triangle. So this triangle is a 30, 60, 90 with the larger angle opening to the root 3. So this angle here is 60 degrees, aka pi over 3. So this entire angle is going to be 2 pi over 3. So that is the base angle that will take us to this reference triangle right here. That will give us these particular ratios. Alright. For other considerations, we do have infinite, infinite coterminal angles, so plus 2 pi k. But fun fact, we're actually not looking for the actual x value for the angle. We're just looking to apply cosine to whatever angle that is. And since all coterminal angles will take us to the all coterminal angles will take us to the same reference triangle, we don't need to really care about those ones. So this is all we truly care about. That's all we need to consider. So 2 pi over 3. So again, we don't care about all the other reference angles because this problem is not asking for specific x values. It's not asking us specifically for the x values that give us these ratios. It's asking us to apply the cosine function to whatever angle that x value is. And again, since all coterminal angles takes you to the same reference angle, we only need to consider one actual value, which will be this easiest one right here. So applying cosine to this particular function. What triangle is that? Well, technically we've already drawn it, right? That's the triangle right there. What are we doing? Wait, I put x right here. I should not write that. So again, we're applying cosine to one reference angle. We only need to care about one scenario. What ratio will that give us? That should give us a ratio of adjacent negative 1 over hypotenuse of 2. And that's it. And we're done with this particular problem. All right. Let's trudge on. We have the next problem up. We're going to be doing kind of a weird situation now. So we have tanks yet again. So tanks is equal to root 3 over 3. And that's statement number 1. And then statement number 2, we have cosine of x. That is equal to negative 1/2. So again, putting these two statements will narrow down our search into one possible scenario, usually. And then the question asks specifically, what is sine applied to x minus pi over 2? Okay, well, this one I'm going to rewrite this, rephrase it as positive 1 over root 3. And with this one, I'm just going to use one xy coordinate system. So tangent of 1 over root 3, that could be right here, positive 1 over positive root 3. Or we have this negative scenario, so negative root 3 over negative 1. So this one could be either of those two scenarios. What's cosine of negative 1/2? We're looking for... Wait, did I mess this up? I think I may have messed up this problem. Okay, so I'll just have to spot correct it. Hold on, let me think for a moment. Yeah, I messed up this problem. So let me just change this just a little bit just to make the problem consistent. So I'm going to change this to negative root 3 over 2. Okay. You know what? For the VOD users, I'm just going to start over. Okay. This is our problem. I don't like the way this is written, so I'm going to rephrase it. It's going to be positive 1 over root 3. So instead of drawing two separate coordinate systems, I'm just going to draw on one coordinate system just to save a little bit of work. So what reference triangle could possibly give us these ratios? Positive 1 over positive 1 opposite to positive root 3 adjacent. So this is one of those possible reference triangles. No, this is a negative one. What am I even saying? I even goofed up before. Alright, so this is going to be positive 1, positive root 3. So that's one possible reference triangle that generates this particular ratio. And then what about this one? Oh no, I'm sorry. We need another one for this one. What's another possible reference triangle that will give us those ratios if we have negative over negative? So we could have this particular reference triangle of negative 1 opposite over negative root 3 adjacent, which would give us cancellations of signs, and thus positive 1 over root 3. So those are the two possible scenarios that would give us this ratio. What about this one? Well, if you look here, you don't put the negative on the hypotenuse, you're going to put it on the adjacent instead. This is a positive adjacent, so we don't need to consider this one. So this one is satisfied with this reference triangle. I'm not going to even draw the other possible scenario for this one, which would be right here, right? So I'm not going to draw that one because this scenario doesn't satisfy that statement. So you don't even need to consider it. So we already narrowed it down. It's only the triangle, the reference triangle in quadrant 3. What angle is that? It's from neutral position up to there. This is a standard 30, 60, 90. So it's pi over 6 past halfways, which is 7 pi over 6. That's the base angle that we are considering. We don't need to consider the coterminal angles because we're just applying a trig function to whatever x is, which we don't care, because all coterminal angles will take us to the same reference angle. So for this one, like last problem, we don't really care about this. So this is the only one that we truly care about. So we're slam dunking that into there For some reason, we're taking away pi over 2. It's some sort of unusual shifting, but that's okay. We can just simply evaluate. So again, we don't care about the other coterminal angles. So if we take this one and we plug it into this one, we're going to subtract pi over 2. Pi over 2. So let's just crunch the numbers. 7 pi over 6. Subtracting pi over 2, which equivalence is going to be 3 pi over 6. So cutting down the numbers just a little bit, we're going to get 4 pi over 6, aka 2 pi over 3. And this is going to be easy to evaluate. It's just going to, if you do the rough sketch, that's going to be pi over 3 short, so we're like here-ish. So the reference angle is going to be pi over 3, which is like 60 degrees. So that's going to be opposite of root 3. Adjacent is -1. We don't care about that since this is sine. And then the hypotenuse is positive 2. So sine of this particular angle is going to be opposite root 3 over hypotenuse of 2. So that should be the final answer for this problem. That is that. And we should be good to go. Yes. Wait, I think there's something I wanted to say about this. Was there anything I wanted to say about this? Well, whatever it is, I kind of forgot what I was going to say, but I think that's good enough. So just to hammer home the point, this one narrows down to, you could just draw this, the potential candidates onto one coordinate system, and whatever is shared, you just focus on that one. Once you get that particular angle, we don't care about the coterminal angles since we're just applying the trig function to it. So we just care about reference triangle. That's the one angle that we're considering. You can plug it into there. Just apply the mathematics and it should be good. Oh, I remember now. Okay. So we don't have to strictly do this one in a number crunching fashion. So there's a property we can exploit given this minus pi over 2. So this one right here is interesting. Okay, so we know this is a reference triangle, so let's take this aside in isolation. So that's going to be -1 root 3 negative and 2. Yeah. So that's what we're considering, right? So that's basically from here to there. That'll be the reference angle. But here's the thing, though. If you think about it... Oh, no, this is kind of a bad situation. Maybe I shouldn't have talked about this. Okay, this is not the perfect scenario. It would have been nice if it was pi over 2 minus x. But, you know what? I'm going to ignore it. That's fine. I was going to say if you subtract 90 from something, it takes you to here. But technically, no, because this one gives us a negative situation. Yeah, it would cause a triangle shift, and we would shift over to right here, which is kind of complicated. And I feel it's not completely worth it. Right? Yeah. I feel that's going to cause unnecessary complications, so I'm going to ignore it. Actually, it doesn't even move it here. It will technically move it by 90 degrees, so we're actually back right here. So it takes us to right here. Since that's not no longer a good valid reference triangle, it's going to be this one right here. So that's going to be root 3 over 2. Yeah. Okay, so in short, this is what happens if you consider the other strat, which I'm not going to emphasize. I don't think it's worth it. Okay, let's move on. Alright, we have 2 more problems to go, and then I'm going to go eat dinner, because I'm getting very hungry. I've ate kind of a small lunch. Alright, what do we have here? We have... Oh, we just did this one. Whoops. We've just done the tanks problem. I've crossed out the wrong problem, unfortunately. Okay, but I can still see it. So this is the problem we're doing. We're doing cosine of x is equal to root 2 over 2. That's first statement, and then second statement. This takes is equal to -1. Third statement, or rather, this is the question. What is sine of x plus pi? This problem looks kind of similar to the one we've just done. So let's start with the given statement right here. We're gonna put both of these considerations onto the same what is it called? Coordinate system. So cosine of what angle can give us a possible root 2 over 2? I don't like this one. It's going to be 1 over root 2. All right. So positive 1 adjacent will lead us right here. Positive 1 adjacent can give us a triangle in quadrant 1, or it can give us a triangle in quadrant 2. Okay. So that's from the first statement, and now we check the second statement. Which of those... Oh, I really botched this problem, didn't I? Oh, I'm sorry. This is not the wrong... That's the wrong reference triangle. I'm sorry. Almost goofed up. What's new? So this is going to be 45, 45, 90. I put the wrong ratios. So this one could give us a positive 1 adjacent, but same quadrants. So positive 1 to root 2 to positive 1 opposite in quadrant 1. Or we can have the reference triangle here. With a positive 1 adjacent, positive 1 opposite, a negative 1 opposite, and then a root 2 for the hypotenuse. So this is quadrant 4. Okay. So we finished considering the first statement, and now consider the second statement. Tangent of x gives us a -1. The tangent for the reference triangle in quadrant 1 will give us positive 1. So we know this can't be the right one. So this one must be the correct reference. What's that angle right there? That's going to give us -5/4. Again, no real need to consider the coterminal angles since we're just applying a trig function to the base angle. So don't worry about plus 2 pi k. Plug it in. And now we just gotta crunch the numbers. It's not too difficult to do. We're gonna get sine of, what is that, 4 pi/4? So all we have is a shift in triangle, in reference triangle, so we're no longer working with this one. We're gonna shift it over following this new set of instructions. So what is that? That's going to be in quadrant 2, generating this as a reference triangle. What is that? That's going to be -1 adjacent, positive 1 opposite, and root 2 for our hypotenuse. Okay. Not too bad. We have a positive 1 over hypotenuse of root 2. If we rationalize root 2 over 2. That should be it. So what is this? It's going to be root 2 over 2. Final answer. Not too bad, right? And then final problem for the day, or at least for now, for this stream. We have cosine of x plus pi equals 0. So I've changed how I've given the clues, right? And now we have sine of x is equal to 1. And the question asks us to apply the tangent function to whatever x value is plus pi/6. So all the arguments are distinct. That's nice. But overall, we're going to do the same strat. We're going to figure out the possible scenarios for this one, and then the possible scenarios for this one, which of those are consistent to each other, and then we're going to plug in the reference angle into here. Not the reference, the actual angle. One of those actual angles into this one right here. So, same strat, it just looks slightly different, but it's the same monster. Different mask, same monster. Let's consider this for a moment. Alright, so what cosine of what angle will give us 0? So we need to find 0 for the adjacents, right? So it could be interquadrant angle number 1, which has a 0 adjacent, or it could be interquadrant angle number 2, which also gives us a 0 adjacent. We don't know which one it is, but pairing up with the second statement, sine of that angle gives us 1. Sine of this interquadrant angle, this is where the opposite matches the hypotenuse in terms of magnitude, but since it's going upwards, it's positive 1, which is positive 1, so it's probably this interquadrant angle. If you look at this interquadrant angle, that's going down the y-axis, so that's actually negative opposite over hypotenuse, which is a negative 1. This is not negative 1. So, not that interquadrant angle. So it must be this one. In fact, I feel like this clue here is superfluous. It feels like we didn't really need the first clue. Okay, so what have we determined? Based off of this one, it must be this interquadrant angle. So again, I feel like this one is a little extra, but let's see if it's consistent. So if we take this interquadrant angle and we add pi to it, it would just take us to this one, which is okay, because this one will give us a ratio of 0 to not 0 hypotenuse. So just to reiterate, that's the only one that satisfies this one. We don't even need this one in consideration. Okay. Now that we know that, what angle is this one? That angle here is pi over 2. No need to consider the coterminal angles, since we're just going to take that and plug it directly into here. So we just care about the ratio in the end. So plug in pi over 2. We're going to be adding pi over 6. And we're going to be applying the tangent function to this one. What is that going to be? Well, a little bit of number crunching. Mismatched denominators, so times 3 to the bottom, times 3 to the top. So we have 3 plus 1, which is 4. So 4 pi over 6, which simplifies into 2 pi over 3. Finish applying the tangent function to this one. Let's do the rough sketch. So in consideration, this one is going to end up in quadrant 2 with a reference triangle of pi over 3 angle. But make sure we account for the negative adjacent to positive root 3. Taking tangent. So this is going to be opposite over adjacent. Final answer, clean up, negative root 3. Final answer. And that's it. So this is kind of a poorly designed problem. The first one was superfluous because there's only one possible scenario for this one. Okay, but I think that should be good for this particular stream. Maybe I'll stream later, but I keep saying that, don't I? Anyway, that's it for now. If I don't stream, then just have a good one regardless. I'll see you another time.